Hi guys. Okay, today I'm going to be talking about ensuring stability of a process. From the other questions that we solved, and the other examples I gave, I said there are three major classes of needs of a control system. That's reasons why you need a control system. In the first video, we talked about suppressing the influence of external disturbance. Now, the second one, I'm going to be talking about ensuring the stability of a chemical process. Now, what this means is that, let's look at this diagram. If, for example, X, that's what you have on the y-axis. If, for example, X is, let me give an example, let's say temperature or pressure, or it could be anything, temperature, pressure, volume. Now, if X is varying with time, now you can see that we have a constant process, that nothing was disturbing this particular process. I'm going to give you a very good example. If I have temperature and I have time, if I have the temperature of a particular system, let's say water, I'm boiling water at a particular time, and as the time is increasing, the temperature of the water is increasing. If, for example, I just pour cold water all of a sudden into this particular system, the cold water will cause instability in the process. That's what this simply means. I'm taking this, for example, if this is temperature, if I have water and I'm heating up this water at a particular time, at some point, if I just pour in, that's I have a change. That's what this means. If I just pour in, let's say, cold water, automatically I just pour in cold water, you just see that your whole process becomes unstable. That means if before, for every, at 10 degrees Celsius, it will heat 10 degrees Celsius for 5 minutes, and it was stable, it was going at that rate. If I just pour in, let's say, 30 degrees Celsius of water into this process, the process becomes unstable, it won't be heating at this rate again. So what this is trying to say is that when that happens, after some time, you see that stability will be ensured again. Now that's what this means. This means that stability, that means the temperature will still come back again to be uniform with time. It means that even after you pour that water in, give it some time, after some time, the whole process will regulate again. Meanwhile, there are some other cases that if you have, there are some variables, let's say, for example, like this Y here now, there are some cases whereby if it's going smoothly before, once you disrupt the system, it cannot go back to how it was again. Unlike this first example, where the system or the variable can go back to stabilize itself again. But in this case, once the system has been disrupted, it is very difficult for the system to go back to stabilize itself again. That's why in cases like this, that's when we bring in a control system. So do not forget, we're talking about needs that satisfy control system. That's the reasons why you need a control system. Now, this will need a control system. It will need a control system for it to be able to stabilize, ensuring stability of a process. So that's the basic concept. That's what happens in these diagrams. So after drawing out these diagrams, you can just explain what each of these diagrams mean. Now, in the second set, dynamic responses of a CSTR. Now you can see it's just exactly what we explained before. In this case, once the temperature has been altered, it's very difficult for it to return back to stability. It just begins to skyrocket and just moving up. Now in a case where, let's say, for example, you reduce the temperature, you know, here the example I gave, I said if you increase it to 30 degrees Celsius, an increase in temperature, okay. Now, but in this case, assuming a decrease in temperature, it just continues to go down. So this process cannot return back to this T2. It can't go back to T2 where it was before. Now let's look at this. Let's call this A, let's call this B, let's call this C, and let's call this D. Now you can see that A and B, they find it difficult. It's very difficult for this temperature to return back to T1. Same goes here, it can't return back to T2. So these two processes are known as unstable process or unstable process. There is instability going on here, so they are known as unstable process. But in this case, you can see that when T1 changes, after some time, it goes back again and continues at that rate. So this is a stable process. These two examples, A and B, they need a control system to be able to stabilize them back. But for example, C and D, they do not need a control system to stabilize them back. So that's what ensuring stability of the system is talking about. That's the basic concept. I hope you guys understood what I explained. If you have any questions, contact me. Bye.